Welcome. Today we spend a second day on 5.2 and we focus on properties of the definite integral. For properties of the definite integral, there are three things that will really help us solve definite integral problems. It is the constant rule, the linearity, and adjacent integrals. So the constant rule says that the definite integral from a to b of a constant is simply b minus a times that constant. Here's a picture that helps us see that. The definite integral from a to b under a constant is really just the area of a rectangle. So for example, using the numbers we have here, the definite integral from 1 to 4 of 2 dx. That simply becomes width times height. The width of that rectangle is 4 minus 1, and the height of the rectangle is 2. So 3 times 2 is 6. The area is 6, I should say the net area is 6, and so that's the value of the definite integral. So that's how we handle constants. How about linearity? Linearity is the idea that I can add and subtract the actual definite integrals. So for example, suppose I have the integral from 2 to 7 of x squared plus sine of x dx. I can write that as two separate integral problems. The integral from 2 to 7 of x squared dx plus the integral from 2 to 7 of sine of x dx. So that's what's meant by linearity. And if this plus was instead actually a minus, then no big deal, we can subtract that instead. And the constant part says if my problem was the integral from 2 to 7 of 5x squared dx, I can make that problem a little bit easier by pulling the 5 out. This becomes 5 times the integral from 2 to 7 of x squared dx. So see how, so far, the idea of using these properties is that they help us simplify problems. They break complicated problems into smaller parts. The last important property is adjacent integrals. So the idea here is, suppose I had the integral from 0 to 2 of x squared dx, and I wanted to add to that the integral from 2 to 7 x squared dx. Well, that would really just be the same thing as the integral from 0 to 7 x squared dx. Now, I'll show you the picture of this in a second, but can you see why this would be so? Here's the picture. So adding the integral from a to b plus the integral from b to c is really nothing more than the entire integral evaluated all the way from a to c. Here's an example problem. Evaluate the definite integral from 2 to 5 of 3x minus 8 dx. We'll solve this problem using our properties. Okay, there it is repeated again at the top of the screen. Let's see what we can do. The first thing I'll do is use linearity, and I'll break it into two problems. 3x dx minus the definite integral from 2 to 5 of 8 dx. I can use linearity and pull the 3 out. 3, the integral from 2 to 5 of x dx minus, then this becomes 5 minus 2 times 8. Now I need to tackle this integral, and I don't have a rule that's going to tell me the answer, but x is a simple function, and perhaps I can use geometry. So let's just draw the function x, that's y equals x, or f of x equals x. 1, 2, 3, 4, 5. So I'm going to go from 2 to 5. So this is the picture of the area that I want. How can I do that? Here's one way I might be able to do it. How about if I take the area of the triangle that goes all the way from 0 to 5, and I'm going to subtract the area of the triangle that goes from 0 to 2. So the area of the big triangle is 1/2 5 squared, that's 1/2 base times height, minus 1/2 2 squared. So that is 1/2 times the quantity, 25 minus 4. So that is 1/2 of 21, so 21 halves, or 10 and a half. All right, So my answer is 3 times 10.5 minus 3 times 8 is 24. So how about 31.5 minus 24? And it looks like the answer is 7.5. So we did it. We figured out the value of that definite integral just using some basic properties and a little bit of geometry. Reversing limits. This is an important idea, and it's often confusing the first time you see it, but it comes up often enough that it's important to get a good handle on it because we'll see it again. So the integral from 1 to 4 of 10. So just by using the formula, I know the answer should be 4 minus 1 times 10, which is 30. But what's going to happen if I reverse the limits of integration? Now I put 4 on the bottom and 1 on top. Well, just by following the pattern, it seems like I should reverse the 4 and the 1. And that's exactly what I do. And the answer ends up being negative. So the picture is a little strange. I have 1 and 4, something with a height of 10. So on the one hand, if I integrate sort of in my normal direction from 1 to 4, the answer I get is 30. But if I do something strange and I integrate in the backwards direction from 4 to 1, then I get a negative 30. In general, if I have two integrals that are exactly the same except the limits of integration of one are reversed from the limits of integration of the other, then these two definite integrals are negatives of each other. So how do I evaluate this definite integral? Well, that's just the negative of the integral from 2 to 5 of 3x minus 8, which we figured out earlier. So that's negative 7.5. All right, these are the basics. This is all you need to get going. So complete the worksheet problems. Don't neglect the worksheet problems. Give those things a try. Check your answers, and good luck. Let me know if you have any questions.